Right, so welcome to 2017 question A-1. This is an axonometric projection question. So the image below shows a Bluetooth mini speaker. The speaker is based on a cube and its faces have been cut. Okay. The drawing on the right shows incomplete axonometric projection of a similar cube, and reference plane is included. The elevation and plan are also shown. So here's our elevation, here's our plan. And the required position, and draw all the visible faces. So basically just want us to complete this view. So just to make things a little bit easier to visualize, okay, I'm going to imagine that this surface here, this front face, okay, is going to be in this position here, and I'm just going to highlight it, lightly kind of shade that in just so you can distinguish the difference between those faces. Okay, just very, very faint shade in there for you, representing this face. And in this face, I'm just going to shade lightly in yellow just so you can make that out as well. That's representing this face. Okay, so we're going to do the basic cube shape first. So that has been projected vertically, and now we need to just double check. Is this 30 degrees? Brilliant, it is. So my z-axis is at 30 degrees, so I can project back this edge to this position. So that is going to give me the cube shape. Alright, so now they want us to find, because we need to complete everything, showing those edges that have been cut out of it. So we have CD, right, which runs from one edge to the other, so it runs from there to there. Now we just need to project back AB, so AB is resting on the base here. So here's AB. Sorry, here's B, so B in that position, and A up here. So A in that position. So I can draw in my AB. Alright, and then we also need to find these lines running at the top. This face in the blue, on the blue face there. So D has already been found for us, and I'll project back this part onto that surface, onto that edge. So that is that line. And we can just repeat that with all the different lines that we've given. If you want to index them, the way they're indexed over here, A, B, C, D, by all means do. I'm not going to, just for the sake of keeping this video short. So, onto those surfaces. That, and then we can see here that from A, so this is aligned with A, so A is going to run to this line, which is on this edge, projected to there, and then just project up all these other points onto, so D, not D, sorry, that one and that one in a line, and they're going to run to the opposite edge. And then our final line on the top surface, project up to that edge, and that's kind of projecting up over to there. Okay, let's go over this edge a little bit here, so make that clear. Okay, so that is the projections that are complete, and just to, I suppose, make life uniform, I did have it shaded the other two views, so I'll shade it here in this view, and yellow on this surface. Okay, So that is part A completed. Determine true angle between lines A, B and CD. So they want us to find the true angle between lines AB and CD. So here's AB, here's CD. Okay? In order to do that, we need to see that yellow surface as a true shape. We need to look perpendicular to it. And if we look perpendicular to it, we're going to be able to see that true angle between them. So we need sliding set squares here to create an X1, Y1 or an auxiliary view. Okay, so that is my X1, Y1, and I'm going to project everything out perpendicular to that. Okay, because this is projected from what is a plan view, okay, it's creating an auxiliary elevation, okay, and over here they also gave us our elevation, so here's our elevation, so I can take heights from there. So the height of the cube, we don't take it from our perspective or from our axonometric, we take it from the elevation, and same this edge. So that's going to give me the true shape of one side of the cube. But that's not what we're looking for. We're looking for the true angle between AB and CD. So we need to locate AB and CD out here. So we actually have to locate them on this surface and project them up. So A is actually already there first. Here's the position of A. B is there. That's B. C then, right? If we bring it down, is actually resting on that point there, okay, or that edge which is running vertical, and the same here with D. Okay, so we're actually going to have to find those in a different method. So I'm just going to bring out my A and B first of all. So A is on that top edge, okay, so it's on the top edge, that height, so I can project that up, and the height is already given to me, or I've already determined it. So that's going to be the position of A. B is on the ground, rather than on the XY line, so that is going to be the position of B. Right? Then C, the height of C can be determined here, and we know it's on that edge running up, so C. And D, the height, same thing, running up along this edge, so I can step that off here. So here's my C, and here's my D. AB drawn, CD drawn, and that is going to find us the true angle between those views. Okay, and I'll just kind of keep it uniform again. I can shade this in if I wanted to. So if it's time these, then we can do that. And let's also just indicate the angle between those. Okay, and probably didn't have to draw the full cube because they're only looking for the true angle between those lines, so I could have just projected up and just taken those heights and drawn my two lines only. But by drawing it, I think it helps for clarity and helps to explain it. And then another method potentially that I could have done was no, you couldn't rotate it. So that's our method there. That's our our auxiliary elevation to find the true angle between them.